Hi on Dave here, look at that! I have a new package here, just arrived, and ooh, I have a new piece of equipment. I just won an auction on eBay, and this is what I got. Any guess what this is? Okay. Power cord. And we have a pretty strange... What is this thing? We have a strange looking kind of probe thing with a BNC connector. Oh, that's crusty. Oh. The actual look at that. Okay. Ooh, jeez, that's pretty heavy packaging, let me tell you. Oh yeah, Jesus, it's a Tektronix. And there it is. So this is a Tektronix 2213. It's a 60 megahertz, very basic oscilloscope, but very cool. Has very basic features, but has everything you need out of a scope. I mean, has a big screen, has all the functions here, all the knobs, very good feeling knobs. Jeez, look at that. It's beautiful. 60 megahertz, still even better than my older one. Has delay time base, has everything you want. Has the original pouch as well, and has all the original manual here. It's perfect, so good, and most importantly has the original probes. But most importantly, I placed that bid because it was sold as is, so I don't really know if this thing works or not, and hopefully we have a very good candidate for a repair. It seemed pretty, you can see this is, what is this thing even? I have no idea. The environment this was, I mean, jeez, that's pretty dirty, but should actually clean pretty good. And most importantly, has all the knobs are intact. Everything seems pretty good condition. We have an interesting sticker here. From Precision Measurements, whatever, date serviced, 11/19/19, are you kidding, 93, so, geez, 11/19, must be 14, but not even close. I don't know, but in 93 was serviced. So yeah, maybe had some problem. I have no idea. Alright, so first I'm gonna actually take the cover off here and see if everything inside is intact before plugging it to the mains, because you never know. A wire inside is touching the case, and it goes bang, and your scope is trashed. So yeah, you'll end up having a very bad day that day. So let's take the cover off and see what's inside. And I mean, the condition of this thing is just, I mean, what the hell happened here? Ooh. What is this thing? I'm gonna check the fuse. See if there is even a fuse. Oh, looks okay. It's one of those spring-loaded fuses. Alright, you can tell that's good. We have 2 screws, and those are Torx, which is interesting. Oh, I get it wrong every time. Jesus. Okay, that must be... Yes. Tektronix Incorporated, Beaverton, Oregon, USA. Alrighty. What the f... I don't know if you can see it, but it's... that's... things falling. Oh. That is... Oh man. Give me a break. Everything on the floor. Okay, much better. Filthy. Okay, so now we should be able to... Ooh. Oh yeah. Okay. It's pretty lightweight. Okay, so look at that. Beautiful. And we have a switching power supply here, which is novel. But they actually claim that's much better, and you know, it's actually much better. It's really lightweight. So under here we have a huge board. Wow, that's a single huge board. Look at that. Look at the size of this board. This is the delay line right there, goes around, and those are the deflection plates. Alright, let's see. I just plugged in to the mains, and let's switch this thing on for the first time. Oh, make some noise. Oh, we have a trace. Let's see. Intensity. Oh, very bright. We can actually move that. Can we make this a little bit faster? Oh yeah. I betcha this thing works. Oh no. Let's see, channel 2. It's right here. Position works. This thing just works. Okay. We have some noise here, which is normal, but center this thing. Okay, and it works. Alright, so the first thing I'm gonna do is I'm gonna remove all the knobs from the front panel. And if you want to remove something like this, don't use a knife like that. Just don't, because you're gonna ruin your front panel. Use a pick. It's so simple. It's plastic. Doesn't, you know, scratch your front panel. It's there are different sizes, and it's a couple of cents. So it's really good for this. I mean, look at that. Coming right off. And for cleaning the inside, I'm not gonna use the brush because there could be some static sensitive components. So I'm gonna actually have a little air compressor here and a vacuum cleaner. Combine the two, turns on, and you're gonna clean this thing beautifully. So let's go. And look at that! Isn't that beautiful? It turned out pretty good. I mean, it cleaned very well, and I noticed some defects here. For example, the power switch doesn't really retract sometimes. It just stays in, like now. Those are just fine. I don't really suggest to you know, spray contact cleaner inside on the just the contacts, because you could sometimes you could actually damage them instead of cleaning them. So just the best thing to do in this case is just use it. And I think there is a little problem with the auto focus and auto intensity. Perhaps it needs some calibration. So after this, and also the trace, I just plugged in a signal and it's not perfectly calibrated, so I'm gonna actually calibrate the whole unit. But have to fix the power button, so have to take the cover of the power supply off. So let's do just that right now. Alright, so we want to remove the power supply shield here. 9 screws holding this shield together. And if you wonder, maybe it's useful for somebody, I have to remove the arm, so this support arm, 2 screws here. I don't know if you can see those, there are 1 and a 2 here. If you have the pre-regulator board installed, you have this one here as well. There is another screw here. There's a screw over under here, and there is a screw. There are 3 screws over here on the back, 1, 2, and a 3 here, and that's all. So 9 screws in total. Oh, we have some Mallory caps. Old school. Perhaps I'm gonna change those. Geez, those look all the way from 90, I don't know, from from the 70s. I mean, geez, look at those caps. Those are, what are those? It's strange. I mean, they used a combination of newer capacitors. Those are Rubicon capacitors, and very old Mallory capacitors. I mean, those are still with the MF, not the mu, to indicate the microfarad. So that's yeah, that's a kind of that's interesting. But I don't know what they why they chose to do that. There is an option, and this is fitted with the pre-regulator board option, which I think is this one here. But again, look at this one here. This is a newer capacitor. Why they used such old capacitors here? And here is a closer look at those old Mallory capacitors. Geez, those are, and they're all over the place. I mean, and there is a sprag under here. Oh jeez, this is old school, and this is not so old. I mean, it's from the late 80s, I think. So yeah, what's going on here? Were they just using leftover parts from other oscilloscopes? Alright, so I removed the plexiglass shield here, and we have to remove the board. Apparently there are a few screws here. 1, 2, 3, 4. Oh yes, there is. It's on the side. Jeez, how many screws? Okay, be careful when removing boards like this one here, because there is, you see this huge capacitor. This is probably alright, this is 450 volts, 75 microfarad, and this is exposed on the back, and there might be some leftover charge. So yeah, I mean, just be careful. Alright, so I love power supplies, and this power supply section, I have to say, that's very clean, very nicely made. I mean, geez, look at that. We have the flyback transformer right there that's tapping right out of the main switching transformer right there, and that's pretty tiny actually to generate more than 7 kilovolts. It's quite a good voltage, but you can actually see what's interesting is you know, the original capacitors right there. And those are the replaced ones, the Mallory. So yeah, we have a selection of Sprague capacitors right there. Those are 4,000 volts rated as Sprague caps, and we have a selection of other rated capacitor. This one is it's a 3 kilovolts one, but why, you know, old and new? It's I don't know. So here it is. The I think this is the pre-regulator board. Look at the big electrolytic here. I think this will be good. I mean, this is a Sprague capacitor, and again, I think this is original, by the way. And we have a Nichicon capacitor right there. And I don't know what's going on with the gunk on the top, but I think that's original. I mean, that's some kind of glue that they put over here to not let the capacitor to leak. I don't know, but it's pretty dangerous this way, because those capacitors are designed to vent in case of, you know, short or whatever case. They actually open up instead of exploding, but by, you know, gluing the top, they probably will explode. Look at that. That is pretty interesting, actually. I mean, this is a case for a transistor that is mounted on a ceramic. Wow, that's that is well, that's interesting. So they mounted the transistor on this special case here, and we have this, which is what is this? It's not a thermal sensor or any sort. I mean, it has a pad on the bottom. I don't know if you can see it, but it has a pad on here. It has a single wire going to, what is this, ground? Yes, seems ground. So this part here is grounded, but it's isolated from this which seems ceramic plate. Perhaps some shielding provided by this this board, which is a board, you know, and has a ground pad, just providing some isolation, perhaps. So the first thing I'm gonna do is I'm gonna just fix the power switch button, which is, you know, is stuck right there. Look, I mean, it's just stuck. I mean, it doesn't come out. So yeah, I'm just gonna spray some contact cleaner with lubricant. So I'm gonna do that just now on here. Perhaps a little bit too much, but will be good. And give it a few turns, and will be good as new. Look at that. First problem fixed. Okay, so I'm actually ready to begin replacing the capacitors, and as you can see, I actually put a little mark on the capacitor that I have to change. Those are 6 capacitors for now, and it's so nice they actually labeled the positive side of the capacitor. So nice. I just made a complete list of all the capacitors I have to change with all the respective values here. So I don't have an ESR meter, but for checking if this one is good, I have a very, very powerful tool. Let me demonstrate that. Here is the powerful sniff test. Okay, Is it good or is it bad? Oh, it's bad, it's bad. Alright, so everything is now back together. I placed the board here on the top and reconnected the wires and everything. Now, I wanna actually try and plug it in, so see if still works. Hopefully it will not explode. I double checked, triple checked the capacitor, the orientation and everything, and everything seems alright, so let's plug it in. And while doing this thing, be super careful, because here now is mains, and also here are more than 7 kilovolts, so that will actually kill you, that will kill you, that will kill you, so everything here wants to kill you, so yeah, just be careful there. Alright, so those are all the capacitors that I have replaced. Look at those, and there's another one here, and so let's see if it still works. Still makes that sound, but seems right. And it's alive. Look at that. Beautiful. Alright. Perfect. Perfect. Okay, so what I'm gonna do now is, while it's on, I'm gonna check the voltages, because why not? I'm here with the thing powered on and doing it carefully. I'm gonna check all the voltages on this board here, and I'm gonna actually show you here. There are all the test points for all the voltages. Alright, so those are all the points, the test points for all the power supply voltages. And if you wonder why they actually jumper linked all the those places here instead of you know, a solid trace, that's because you could actually you know, troubleshoot the thing and you know, just unsolder one of those pins, just lift it out and test it with a load, so you can actually test the power supply without powering up the whole oscilloscope, which is a very, very clever feature. Okay, so now let's measure the voltages, and so hopefully you can actually see here on the multimeter. Okay, so we have a bunch of voltages right there. We have minus 8.6, plus 5, plus 8.6, plus 30, and plus 100. So have a ground test point right there, and this is the minus 8.6 starting from here, and that's pretty close. Let's see another test point for it. Alright, that's good. Plus 5. It's pretty good. Plus 8.6. That's nice. Plus 30 volts. It's a little bit low, but there's no adjustment for it. So plus 100, which is right there. That's pretty good. So that's all looking good, and I'm pretty happy with it. Perhaps I'm gonna adjust the there's only one adjustment right there for the minus 8.6, but it's, man, that's pretty close, so I don't think that needs any adjustment. Alright, so continuing the the restoration of this, I really wanna spray some contact cleaner on the switches, and especially on some parts like this push button, the push button here, that is not working. I mean, it's not retracting. Sometimes it does, sometimes does not. So as you can see, it doesn't really work. So I'm gonna actually spray some contact cleaner with lubricant, so what will actually be perfectly good. And by the way, look at those pots. Those are very nice AB branded pots. Just a tiny bit. Okay. So this was the push button. Okay, now it's beginning to work again. Look at that. Beautiful. So we fixed that, and you have to, you know, use it for a while. Then we'll actually come back good. So let's clean the excess here. Also here. I want to spray some contact cleaner also on the on those switches, because some of those are a little bit stuck. So just a tiny little bit of contact cleaner on all those. Okay, is now everything back together again, and I just checked all the voltages again and again. So yeah, pretty sure it's alright. So I'm actually gonna end up this video here right now, because I'm actually running out of memory. So in the next one, I'm gonna actually perform a full calibration of this unit. So again, thanks for watching, and I'll see you next time. Bye.